Greetings! Welcome to the Alloy 3 Crash Course video, where I'm going to be covering basically the whole set very broadly, very quickly, to give you an idea of the various sorts of shaders that are in the set, tips and tricks for authoring maps for them, setup instructions, update tips, and hopefully by the end of this you should have a general idea of what Alloy can do for you, the range of tools that are within its palette, and we'll feel confident enough to jump in and use some of the more exotic tools that we've included. So let's start out with importing Alloy into a fresh project. I've just created a completely empty project here. I've imported the Alloy package from the store. The first thing you're going to want to do is unroll your packages folder here and import the alloy3.xx, whatever version number is the current, shaders and editor core.package. I'm going to double click that. It should look something like this. And then I'm going to hit import. Obviously this will take a bit, so I'm going to pause my recording. Wonderful. We're all imported now. We can see that we have a scripts folder which has all of our inspector goodness and all of our shader folders. The actual shader files, if you're curious, are down here in SM3. Everything else pretty much is various sorts of headers and resources and such. I'm not going to import the SM5 package right now. It contains the tessellation variants for pretty much everything in the set, but I'm not going to be covering those right this moment, so there's no reason to wait, the 5 or 6 minutes that it would take to import. So once we have that imported, let's go ahead and set up the few things that we need to in terms of project settings to use Alloy correctly. The first of these is to go to Edit, Project Settings, Player. Ensure that we are in linear color space. I still don't know why this defaults to gamma. Just irks me. If you're going to be using deferred rendering, go ahead and pop into it. I'm going to stay in forward for now. And then go into Edit, Project Settings, Graphics. If you're going to be using deferred rendering, you're going to need to use the Alloy Deferred Shader Override. So basically, under Deferred here, switch it from Built-in Shader to Custom Shader. And then under Shaders here, you can see in the project view, I have Alloy Deferred Shading. Just drag that up to here. And now Deferred Shading should work correctly with Alloy. And then last, and this is just a silly little thing, go ahead and open up your quality settings. By default, a new project in Unity 5 defaults to Fantastic quality, which is fine, except for the fact that anti-aliasing, or MSAA in this case, is enabled by default. And the problem with this is that silently disables HDR, whether or not you have HDR enabled on your camera or not. So what I just tend to do with a fresh project is I go ahead and blow out the other quality settings. Those would have to be set up carefully and manually anyway for whatever it is that you're making. Set anti-aliasing to disabled. I tend to leave everything else as it is. Fantastic is a great high fidelity starting point. You may want to set shadow projection to close fit. I find with stable fit, you get a few more holes with your directional light shadows on thin geometry than with close fit. Awesome. And then lastly, make sure with your camera that you have HDR checked. And towards the end of this, I'll also be covering my image effects setup. We're going to obviously want more than just turning HDR on. We're going to put on bloom and tone mapping and things like that, but I'll cover that a little bit later. Now, if you are updating Alloy later on from the store, what's going to happen is that these two core packages, and sometimes the Alloy mods package, are not going to be overwritten. You're simply going to get a new sub-package. This will eventually say Alloy 3.1.2 or Alloy 3.2 Shaders and Editor Core, just so that you can roll back to an earlier version if you need to. Now, while this isn't absolutely required unless the version-specific README says so, I tend to always blow out my Alloy directory before updating, just because Unity isn't always aware when shader header files change. It doesn't automatically re-import shaders. So you can sometimes run into errors, or you'll update and something will go missing. So the easiest and cleanest way to handle this is simply to open up a completely fresh scene. Most importantly, make sure that you have no current script errors in your console. If you do, then when you re-import Alloy, it won't finish compiling all of the script. So always make sure if you're updating Alloy in a project, you have no standing scripts that prevent the assemblies from being updated. Then, just as I said, do this in a blank scene. Don't do this in a scene with a bunch of other things. Just select the Alloy directory, blow it out completely, and then download the update if you need to. So now that we've covered importing Alloy and updating it, I've jumped over to a different project where I already have a bunch of things set up to play with. I have Alloy imported, I have several of our content packs, our detail maps and FX maps imported, just so I have a bunch of stuff to play with. I've also gone ahead and imported the standard assets image effects for handling setting those up for your scene later, as well as, of course, Sonic Ether's Natural Bloom. You should all have this in your project. If you don't yet, shame on you. Anyway, so let's first take a look at the Alloy Shader Inspector. I have a sphere here set with just a brand new material that I've set to Alloy Core, which is the sort of workhorse of the set. Most of what you're going to be working on, you're going to probably be using Core, unless you have some sort of specialized asset. So in the inspector, you can see that we have a rendering mode drop-down. This is for selecting opaque, alpha cutout, transparent, and fade. The difference between these, and this is true with the standard shader as well, is that a transparent shader, in this case, let's play with this. Let's knock its alpha down. You can see even at an alpha of absolute 0, we can still see the object here. And this is because this is physically correct transparency. We're still seeing the specular reflection, even though the object is completely transparent. Fade is not physically based transparency, but it's still necessary from a sort of utility standpoint. An object being completely transparent in fade mode means you want that pixel to just go 100% transparent no matter what. No matter what the other physical parameters of the object are, it will simply fade all the way out. And this is useful if you're creating objects that, say, have fringes on them. This is useful for certain cases of hair, and generally different sorts of imposter geometry in a similar context that you would use something like alpha cutout. We then have a global illumination drop down here, and this basically controls for the material anything that would be emissive, such as the masked incandescence property group I'll be covering in a bit, emissive rim lighting, things like that. If you want them to affect the enlightened GI, that's something that is determined per material. And that drop down is always up here whether or not you have one of those emissive property groups enabled or not. Going down below that, we have these collapsible rollouts. And as you can see, we only have 2 here because this is just a default core shader. You have a tint up here, you have a base color map. You'll notice there's only one set of texture transforms here. And basically, anytime you see this, you can basically assume that implicitly this set of texture transforms controls the entire group of what's listed below it until you see another set of transforms or you jump to a new rollout. For the default Alloy shader, we have a base color plus opacity input here. We have an Alloy packed map input here, which I'll cover in a moment, a normals input, and a vertex color tint slider. And this shows up on pretty much all of the shaders, but if you want to import a mesh that has RGB vertex colors, you can blend them in multiplicatively here, and this will just multiply against whatever's in the base color and whatever tint you've set here. And then lastly, in the core shader, we have a main physical properties. These values, once again, are multiplied against the values that are in a packed map. And so these are here primarily for testing purposes. If you haven't yet specified textures for these channels, or if you don't need them. If you're making just a simpler material, you don't need per pixel information for whether something's metallic or rough, etc. You can just use these solid values. And so here, removing the material between 0 and 1 metallic. Here's the sort of normalized specular F0. This, remember, is only relevant if you have a non-metal. If we have a metal, this value is completely ignored. And remember that this range is basically monochrome specular F0 between 0 and 0.08. If you don't know what that means, if you haven't been reading up on PBR theory yet, just know that the when in doubt, the sort of average value to use is 0.5. If you're not specifying it via map, if you don't have a chart to look up, or if you don't even really care that much about this value being super precise to physical values, just put in 0.5, it'll work. If you want it to be as diffuse as possible as a material, knock it down to 0. And then lastly, obviously, we have roughness here. Beautiful. So I mentioned before that we have this alloy packed map input here. You can see it says metal R, AOG, spec B, rough A. We basically, because these are all monochrome values, we pack them into a single map so as to not waste texture samplers and not waste data that we're just sort of having hanging around in memory. And so to make the process of packing these more convenient for you, we have this system called the Alloy Material Map Channel Packer up here under the root window menu. I'm going to open this up. So we have several different types of packed maps inside Alloy. I'm just going to deal with the primary one here first. There's also one for doing detail and terrain, which I'll cover later. The way this functions is that we can assign textures that we've brought in from Photoshop or Substance Designer or what have you. They can be multi-channel, they can be single-channel, it doesn't matter. They're going to be packed down the same regardless. And so I'm going to just do this with a material that I've brought in here. I have this set of textures for sandstone. I've got a base color, an ambient occlusion, I've got a height map, a metallic, which is just black because it's sandstone. I don't even know why I have a texture for that. Normal map, and roughness. So what I'm going to do is I'm going to drag these in. For the metallic, I don't really need to drag this black texture in here. I can just hit black if I want. Instead of specifying a texture, you can specify a default value. You can even set this as a custom, so if I wanted to do 0.8, I could. So black there. Drag the ambient occlusion map up there. For the specularity, once again, I don't have a map for it, and if I wanted to tweak this by eye just using the slider that's in the shader, which is what I frequently do if I'm not specifying a map, I'll just set that to white, so it's multiplying 1.0 by whatever value that slider has. And then for the roughness map, set that to texture, drag roughness in there. And then the last input here is, you can see it's specifying a normal map. Now this doesn't mean it's packing the normal map in. This is for something called roughness correction, where basically what happens due to MIT mapping is that as you get further and further away from any sort of noisy normal mapped object, a lower and lower MIP for that normal map is being displayed, which means that because this is going down in size, pixel-wise, it's necessarily sort of flattening out. What this means is that materials that are sort of middly rough and very noisy on their normal will necessarily look smoother the further they get away from you. And so what roughness correction attempts to do is bias the MIP levels of the roughness in the packed map to compensate for this. Now this isn't something that I would recommend you put on every material because it takes a little while to do the texture processing to do this. I tend to use this within my own workflow when I'm seeing that type of artifacting occurring at distance. So I'm going to skip it for now. But I tend to use this especially for noisy materials that are like middlingly rough metals. I use this very frequently. And so now we need to make sure that this is going to put the packed map in the right spot. I'm just going to left click on one of these textures so it sort of grabs the directory. I'm going to delete the suffix there, so I'm going to get sandstone underscore alloy PM and hit generate. This will just take a second. Beautiful. I'm going to go ahead and close that. You'll see now we have two files in here. We have a texture, which has already been set up in terms of its import settings to be correct. If you take a look at it, we're in advanced mode. We have bypass sRGB sampling enabled. We're in trilinear filtering mode. In general, you shouldn't ever have to play with this. If you do need to pack your maps in some other program for whatever reason in your pipeline, just make sure their texture import settings are the same as you see in a map outputted from the packer. And then we also have this custom asset file, and as you can see here, it looks suspiciously like the material map channel packer window. And the reason for that is it is remembering these connections to these textures and values. We can set this up to auto-regenerate if we want. So say if we were iterating on this material in Substance Designer and outputting sort of final maps, we could just check this box and make it so that any time Unity detected that any of these maps changed and re-imported them, it would then also regenerate the packed map after that. Don't need that for now, so I'm going to go ahead and turn it off. Awesome. And then the last thing to remember about the packed map system in Alloy is that this is importantly not a texture, even though it looks like one. If I right-click this and click Show and Explore, you'll notice that this is a 1 kilobyte file. And that's because it's storing this packed data in the library folder of your project. And so if you're packaging this to move to another project or to give to another artist, it is absolutely critical that you grab this whole directory, meaning that you grab not only the packed map, but all of the source maps going with it. Or what's going to happen is that they will import that packed map, the custom asset will look for the referenced assets, and it will be like, I don't know where your textures are, bro. And it's going to give you, a white 4-pixel texture that isn't going to be useful. So always make sure, don't trust Unity's dependency checker when you go to export your package. Always make sure that you're grabbing a whole directory that includes those source maps so you don't lose anything. So now that we have that, let's go ahead and throw this on our core material. Set that tint to white. I'm going to drag all these values up to 1 so that they're just allowing the packed map to control those values. So we have our base color. Someday I'll learn not to call that a diffuse map. Old habits die hard. Throw in the normal. Beautiful. So now we have our sandstone. Let's repeat that a few more times. And then we can, as I mentioned before, I put a white value into the spec. We can control this here. Being sandstone, this probably within that range has a fairly low specular F0, probably something like 0.35 to 0.4. Looking good. So now that we've covered the material map channel packer, let's talk about what's different with lighting in Alloy. So to do this, just because it's easier than demonstrating with just a sphere, I'm going to create a quad here and go ahead and put the same sandstone material I have onto it. There we go. And I'm going to go ahead and nuke the directional light here. It does look a little strange with just the IBL, but we'll fix that in a moment. And I'm going to go ahead and create a point light. Now when I create this light, you're going to see in the inspector now there's this convert to area light button. Always click this with a point and spotlight, or they're just not going to behave correctly. What this does is add an extra script component that controls size. Basically all point and spotlights are spherical area light approximations. an alloy. So to demonstrate this a little bit better, I'm going to take the normal map off of this for a moment. And I'm going to make it a good deal shinier till we can see the specular highlight here. So here at pretty much max or minimum roughness, we can see that we have a punctual highlight on this point like how we're used to. But with this size parameter here, which will go basically from 0 to whatever the light range is, we can see that instead of having a point, we actually have an energy conserving large specular highlight. So I'm going to go ahead and crank the intensity up. Another change that's happened here is that your light intensity is not clamped to 8. And we did this in part because we're not using Unity's lighting fall off. We're using inverse squared fall off, which falls off much more rapidly than you're probably used to, but I find gives things a much more physical, realistic look. You do tend to have to use a good deal more lights, though, to really fill out an interior environment, especially if you're not using GI. So we can see here we have, as I said, large highlight. Let's pull the roughness back down to see how that looks and behaves. Pull it back up. The one thing you have to be very careful with this, though, is that this approximation falls apart utterly in one context, which is if this sort of size widget here actually intersects the ground. You can see as I do so, we get this terrible intersection, and there's just no way around this with the way that this approximation works. So if you're creating area lights, you want to, and you aren't using, say a custom cookie to cut off part of it, to cut off one direction of it, you always want to make sure that these are not intersecting the ground. But beyond that, do have fun with them. Wonderful. Oh, and just while I'm here, I might as well do this. Let's go ahead and create another script. If you want to, because of just the way that the script component works, if you want to change certain parameters about a light via script, you're going to want to, let's go ahead and open up Visual Studio here. You're going to want to actually grab the alloy area light component that's on it. And you can see here there is a color parameter. Let's just go like this so that it completes. There's, as well as if you wish to change the intensity. Once again, because the way we're rolling it together into an HDR color to get around that bounding, you have to change this in the alloy area light component, not the light component. And similarly, get component dot, size. You know, I could do something like, say, get component light. Obviously, you should be caching these, but just for example purposes, beautiful. So something like this during update would set the light to color to be green, its intensity to be 16, and its size would be exactly half of whatever you had set in its range. So that's playing around with lighting in Alloy. So now that we've covered lighting with Alloy, we're going to start talking about property groups. So what are property groups? Basically, every Alloy shader is a sort of Uber shader, in that there are a group of extra properties, hopefully that pop-up window actually shows up on the screen recording, that we can add to our material. Note that you can't do this at runtime because this is actually compiling a completely different shader variant. So in the case of Core and most of the shaders in the set, we have this set of sort of 8 default property groups, which over the course of developing and using Alloy, we've decided are the most sort of common needs assembled in basically the most texture efficient configuration that we've been able to put together. And so let's start playing with one of these. Let's say Parallax Properties. So we can see that this gets added in as an extra rollout here in our material. Property groups can have everything from texture inputs, parameters, mode drop-downs. It really depends on the feature. In the case of this, I want to add some POM goodness to this sandstone material. So I'm going to click this drop-down, click Parallax Occlusion Mapping. This is the more expensive of the two parallax modes, but general parallax mapping I've never really been a fan of. It has its purposes, but I don't tend to use it very frequently. So this takes, we can see this takes in a height map, which is reading from a green channel. So I'm going to grab sandstone height here and pop that in. Wonderful. We can play with the height here. Note, POM is one of those features where the properties that are here totally give you enough rope to hang yourself with. In that this min samples, max samples range is the minimum and maximum number of samples to the same texture to get your given effect, which means that you always want these two to be as low as you can get away with in terms of having an acceptable aesthetic response. You don't want this, like, say, set up to 50 to 200, even though it's going to be super perfect when we get really close to it. You can see that we don't see any sort of sampling striation here. Well, just a little bit. But this is simply an unrealistic amount of samples to use on this. 4 to 20. Once again, if we get super close, we can begin to see some artifacting of it. There we go. So if you get right in there, you can see that effect fall apart. But in almost all contexts of using it, this should be a good sampling range. Just be aware that the place where POM really falls apart badly is when your height map has this super sharp transition of depths within a single pixel. So if you're going from pure white to pure black, POM is not going to look good no matter how many samples you throw at it. It's just too rapid of a transition, much like a normal map bake pull where something isn't beveled out enough. If you have too rapid of a transition, the illusion falls apart. But that's basically all you need to know about it. Man, that looks wonderful. Awesome, so that's Parallax Properties. Let's go ahead and nuke that back off. Let's take a look at the next one, AO2. This is a sort of specialized one that we added in largely at the request of some folks who are doing ArcViz work, where you are in a context where you want to use a lot of repeating materials like wood, stone, etc., and but still want to do, say, a V-Ray bake or something like that, where you have nice per model occlusion. This basically allows you to just specify a second occlusion map that functions the same way as the occlusion that goes into the packed map, but allows you to pick a second UV channel for doing it. So if this doesn't sound useful to you, it's probably not, but there are definitely certain sorts of environment authoring contexts where this allows you to repeat the usage of so many materials in the same scene. Awesome. Next up, detail mapping. So this one I use constantly, enough that I created a package for it. And there are a couple things to understand about the way this functions. Basically, we have, for inputs, we have a mask which reads out of alpha. So if you don't want detail mapping to appear everywhere, you can attenuate its appearance. We have a weight, which I should probably put some maps in before I start dragging that around. And you basically have a color, normal input, and a detail packed map input, which is basically just ambient occlusion and something called roughness variance, which is basically, it's the roughness correction system that we have in the packed mapper that varies the roughness of the underlying material based on the noise of the detail normal. And this functions purely to help smooth out possible sources of artifacting. So let's go ahead, let's do this simplest approach for this, which is just to grab a detail mask off of here. Map set, let's see, rocky. let's see what we got here. Okay, so that's a little too sharp. Yeah, let's add craggy here. So we'll grab craggy 1 normals, so we'll pop that in. And then we want its detail packed map, which, oops, those look like those need a quick re-import. Gonna do that now. Awesome, finished importing. What basically happened there is that Anton dragged all of these just in Explorer from another project into here, and they didn't import correctly. Anytime you see a alloy DM, so a detail packed map, and it doesn't look primarily green, what's happened is that this just hasn't regenerated itself. And so you oftentimes just want to right click that directory and click re-import. This actually reminds me, after you import alloy, one of the things that you need to make sure to do is that in the resources directory under shaders, there is a default alloy DM that basically gets plugged into a material by default when you add the detail property group. If you see this texture and it's not green, it means it needs to be re-imported. Otherwise, basically what happens is that the roughness variance is just going to step on the roughness of the underlying material. An example of this is here. I'll just do this so that you can see what this error looks like. So I have a smooth material. It's very obviously smooth. If I remove this detail packed map, because it has no input, it's going to completely step on that roughness and send it all the way to 100% rough. So always make sure you either have a detail packed map that you've made or just the default one here. Otherwise, you will lose all of your glossy goodness. So cool. So as I said before, we have this craggy, let's make that largely rough again. We have this craggy detail map. We can repeat this multiple times to add in further normal detail when we zoom in. And if we wanted to, we could even say blend over our sandstone color, again, also repeated. As you can see, that made that darker. For this reason, there are 2 blending modes with detail mapping. There's Mull, and then there's Mull X2. And what Mull X2 basically tries to do is blend the 2 colors together, but keep the overall luminance of the result about at where the input was. It can sometimes do some strange things if you're blending, say, non-complementary colors together, but I tend to use this most frequently. Wonderful. And that's detail mapping. Also, something of note, just because in this example I'm removing other property groups before I add new ones doesn't mean that you have to do that. You can have many of these active at once. There is a limit, which can sometimes be a little hard to predict. Just because of the nature of this, there's no way for us to exactly predict ahead of time whether something's going to fail. You'll basically just get an error at the bottom if you add too many at once. And that's from just exceeding the unique texture sampler limit on a material, which is somewhere, based on what GI mode you have enabled, that's between 12 and 14. It's a little hard to do, so you probably shouldn't run into this as a problem, but you should be aware of it. Wonderful. I'll actually keep the parallax on there for now. That's pretty. So that's detail mapping. Weight off, on. Cool. Now let's see. Okay, TeamColor. TeamColor is a module that we added, especially after seeing one project we were consulting on where someone had basically had red and blue teams in their game, and they had created unique textures for every single asset in their entire game for red and blue teams. And this is just an absolutely unnecessary amount of bloat. And so what TeamColor does is it takes in an RGBA mask set and allows you to tint specific regions. So I'm going to do this very quickly in Photoshop just so that you can see what this looks like. Let's just start with a black canvas here. Let's create I'm just going to do it RGB for simplicity's sake, although you can use all 4 channels if you would like. And this is not unlike using a mask set in Substance Designer, where you're doing multi-material blending, except in this case, this mask set is just being used for the base color. So let's save this into our project, TeamColor example. Let that import in. We can drag that into our masks channel, and now different areas of that, we're repeating 3 by 3 here. We can now multiplicatively blend each of those different regions based upon the mask. Let's do one orange. Wonderful. And the beauty of using this alongside Metal Rough is that this is tweaking the base color, not the albedo or just say the diffuse color, which means that you can come up with a schema for the way in which you're using these 4 channels, say if you're using it across an entire project. So you could do something along the lines of like primary dielectric color is red, secondary dielectric is green, and then primary metal is blue, secondary metal is alpha. And then you have 4 controllable values across, say, a range of environment and character assets that all use the same sort of consistent schema. And what you would basically just do if you wanted to control that color tinting across all of your assets is you would just leave those regions white or light gray on your base color map and just use this property group for the tinting. So now that we have that, let's nuke that back off and see what's next. Decal Properties. This one's super simple. Basically, it just allows us to alpha blend over onto a primary material and RGBA texture. So let's grab ourselves an example. I have a decal example here. It's just an RGBA texture. We've got a red to blue gradient in RGB and then a mask for alpha. Whoops, that's backwards. Let's invert that. Beautiful. Text is white. Hit save. Go back into Unity here and then throw this into the base color opacity channel, and beautiful. That's being alpha blended over. And so we can attenuate the weight of this as we want. We can change just the specular of it. Basically, the decal will always draw as a dielectric. And we can also, if we wanted to, we could, if we had Vertex alpha here, we could modulate the tint of it as well. And this has its own set of texture transforms as well. So if you want to say, reiterate the point of decal testing, woo, we could repeat it 5 by 5. And note, this isn't just useful in terms of putting decals on. This is another way if you wanted, if you've, say, already made a material, you've got detail mapping on it for lots of cracks and such, and then you wanted a sort of grime layer on top of that as well. You could totally use the Decal Properties and just have a very sort of noisy, super subtle dust layer that you're blending over that. Wonderful. Onward, what do we have next here? Emission Properties, my favorite. So the way our Emission Properties group functions is it's doing what I call masked incandescence. What this means is that instead of just having a single glow map, you have a sort of map with its own texture transforms that can move and scroll about an object, and then you also have another input that can function like a mask. So let's go ahead and turn this, ooh, goodness, let's put some textures in first. So I'm going to grab some caustics out of the Alloy FX map pack here. We'll just throw these in, Caustic Swirl 2. Now we'll turn the weight up. Beautiful. So this has the standard sort of texture transforms, tiling, offset, and scroll. We can start that scrolling on one axis. We'll have to hit play to see it in action. Come on, Unity, you can do it. There we go. So now that's scrolling. Let's change it to -0.2. But in addition to having that sort of animation, let's say we had a mask for our model where we wanted nice scrolling emission, but we only wanted that emission to show up in certain places. We could also throw a mask texture into it. So now I've used another one of my caustics here to sort of zone out where that's occurring. And to make that a little easier to see, instead of having a caustic in there, let's put Firestorm in for the effect. There we go. So now you can see that the emission texture effect is scrolling due to these settings here, but it's only occurring in regions that this color mask has dictated. And note that this mask is synced up with whatever the texture transforms of the primary material is, as that tends to be the most sort of common usage, is to make sure that the mask always remains synced with the main textures. Something to be aware of in regards to all emissive effects in Alloy is that we're using an intensity gain slider. So this is exponentially increasing the value internally with a value from 0 to 1 so that you get a sort of perceptually linear increase in brightness. And of course, we don't really have a bloom effect on here at the moment, so let's fix that momentarily. Image effects, make sure we're in HDR, bloom intensity, image effects, color adjustments, tone mapping. There we go. So that's the way that the Emission Properties group functions. Let's pull that back off. Rim emission functions almost identically. It isn't masked the same way, but it still has a texture input in case you didn't want to use a solid value. We'll do it with a solid value first. Let's just give it some nice glowy blue. Set the weight to 1. Pull up the intensity gain. Beautiful. And we have two further parameters here. We have fill, which basically can be used to just draw the rim from the edges all the way towards the center, which can be useful for certain things like spell effects and such. And then we have a fall off, which just controls how tight or how wide that rim effect is. Now, once again, this doesn't have to be a solid color. We can totally just have this tint multiplying against a texture. I'm going to move the plane out of the way because this looks a little goofy on it. But once again, I can set the scroll on this. Let's pull the intensity gain up a bit. Make the fall off tighter. Beautiful. So now we can have a rim effect that is both not constant in color and isn't quite constant in shape because we have a high contrast mask on it. So useful for everything from spell effects to shield effects to, hell, I just want rim lighting on that. So cool, have fun with it. And then lastly, we have something called Dissolve Properties. And the way this works is this takes in a slightly more complex texture, which is that it takes in a glow color and a transition mask. And so what I'm going to do to assemble this is I'm going to go ahead and open up, say, one of my Firestorm textures for RGB. And then, just because I have it handy, I'm going to actually use the height map for the transition. And this will all make sense once I composite this together. So I'm going to grab this. I'm going to pop it into the alpha channel here. Oh goodness, are these different texture sizes? I feel like an idiot. Oh goodness, that's 8K. Why is it 8K? There we go. Back to sanity. And then we'll go ahead and save that in Alloy Crash Course, Textures, Dissolve, example. 32-bit. Let's plug this in. So basically, the way this functions is that we have a cutoff parameter similar to alpha cutout. And what this does is it treats the height value that is in the alpha there almost as in a start and an end to an alpha cutout dissolve. And this was originally put together when I was working on a destruction system for a combat game, where I wanted, instead of an object to just sort of pop out of existence, to actually sort of burn away. And that's how this this function. So if I drag the cutoff value here, you can see it's using the height map to slowly burn away the object. But it functions, and then you're probably like, well, why the RGB? Well, the reason is that for this to truly hit its VFX potential, in addition to the sort of burn away, we have a glowing edge, and that's what the RGB color is for. So let's turn up the gain on that, and then we can manipulate the width of that burn away effect. So now instead of just alpha cutouting away, we can make that dissolve appear to be more energetic. Wonderful. Perhaps a little bit niche in terms of VFX needs, but I like being able to use it on damn near everything. So it is there as part of the default property group set. Wonderful. So that covers it for property groups for now. In the next section, we're going to be talking about the actual different shaders in the set beyond core. So we've talked about adding property groups to the core shader, but obviously the alloy set is far more than just the core. So let's take a look at the alloy directory here. We're going to be covering almost all of these, at least in brief. As I mentioned before, core is the workhorse. Another one that sort of is in the, shall we say, the standard set that may be of use to you is prototyping. Note, this is not a production shader. Please don't actually use this in a final build. The purpose of prototyping is just if you don't want to be going through the map packing process to be testing things because of the way that your texture import iteration process works, and you need them as separate channel inputs. Once again, just for testing purposes, this is here for you. You can just drag in the special maps. You don't need special texture import settings for these. You can just use them straight for metallic, AO, spec, and roughness. So once again, please, please, please don't ship anything with this, but it's here if you need it. Beyond that, we have CarPaint, which is one of my favorites. I think I've used it at this point for everything except an actual car, as I don't have a good model for it. But the way CarPaint works is that we have these extra property groups here called Paint and Flake Properties. The way this works is that we have, at first, angle-dependent hue. So I'm going to go ahead and plug two separate colors in here. This is for that sort of delicious chameleon paint job look, where you have sort of one color blending into another. You can change the fall-off for how it's going between color 1 and color 2, as well as the weight of the effect. Beautiful. In addition, we have something called Flake Properties, and what this is it allows you to put a layer of sort of specks that are going to appear in a semi-angle dependent way. So let's go ahead and throw a flake map in here. Where do we have one? I know I've got one here somewhere. One moment. There it is. It was down in Alloy 3 samples if you're looking for the sample flake maps that have been included. They're not in the core pack. So let's go ahead and drag one of these in here. I'm going to put the Gaussian noise in. And in general, you're probably going to want this to repeat at least more than once. And we can see that we now have that noise being blended in. Note that there, just because of the way that metals and various colors blends, you can accidentally create some pretty hideous combinations here. And so it's generally a good idea to make sure that whatever the tint of your flakes are, it's brighter and a little less saturated than whatever your primary and secondary paint color are going to be. And so with these flakes, you can once again, you can attenuate their weight, you can attenuate their spread, which is just generally from a straight view angle standpoint, how much they spread across the surface based on angle, as well as how much they sort of spread out from bright points. You can see that changing around our highlights there. And for another example of this in use, because you can also mask this out in the base color map, the Arum character sample in the Alloy 3 samples is actually using the CarPaint shader for the entirety of the body. Basically, I've masked out, in the case of the arms here, the metallic areas such that we have a sort of white to purple CarPaint effect here. I'll just change the hue so it becomes a little more obvious. We're blending again. There we go. I actually have a base hue in the base color map, so the effect is a little less noticeable here. Same thing present for the boots, in that we can see this red coming in at the angles over the orange parts that have been masked in. It's a subtle effect, but I love using it. In some ways, you could think of the CarPaint shader as much as a sort of opalescence shader as anything else. Anytime you want to represent some sort of complex synthetic or a sort of layered material where you have angle-dependent hue and sparkles, the CarPaint shader is going to be useful for you. So now that we've covered CarPaint, let's move on to the next one. This is a relatively recent addition to the set. It's called Directional Blend, and so this is in the category of sort of two sub-material materials. I'm going to pick Directional Blend World here. And the way this functions is that instead of just having a main textures and main physical properties, we have a property group for a whole sort of second sub-material. And then we've got Directional Blend Properties that allows us to blend them together. So let's go ahead and configure the first one with our sandstone material. Beautiful. And the way this works is that we're essentially blending material 2 over material 1 based upon some set of parameters. In this case, a facing direction. And so I'm actually going to nuke the normal map out of this so that we can more clearly see what's happening without a bunch of noise. What we have is, under Directional Blend Properties, we have a direction that material 2, let's go ahead and make it red, is being blended over our sandstone. And we can control the weight of this blending. We can control the cutoff, so basically where we're sort of reaching 100%. And then we can control the blending range. So I can pull this all the way down to a dead perfect line, or I can say bring the cutoff all the way up to the top and have this be a super gradual blend. Now this doesn't have to be on sort of like coming from above. Basically we have a Euler rotation matrix here, and I can rotate this blend direction. Now by default this is occurring in world space because we're using blend world. So if I rotate the object, that blending direction is going to be the same. But if you want it to actually follow the object, you can instead use blend object. Where'd it go? Okay, never mind on that. There appears to be something wrong. Oh, there it is. There's our cutoff. It must just treat that value slightly differently. There we go. And as you can see, it actually sticks with the object. There we go. I think there's just some slight axial difference between blend object and blend world. It's a new shader. We'll get that cleaned up. Don't worry about it. Wonderful. And so obviously I took that normal map off before so that we had a sort of, in some ways, a more boring, clearer to see blend. But let's set this up a little more like how we would actually want to use it. So we'll have the sandstone there. As you can see, because material 1 has a normal map now, this is actually changing the facing direction for each pixel, so our blend comes in way more chaotically. Now, for our second material, we can actually just put some sand on it. Sand. Do I have a packed map for that? It does not look like it. Sand. Normal. Beautiful. And we'll just set that to be not metallic, mostly rough, not very specular. And obviously not red. So there we go. So now we have sand blending over the sandstone with its own independent texture transform. So if I wanted to say repeat that 4x4. Beautiful. And we can control, I might want to bring the cutoff back even more and then just have the blend range go out further so it's a much softer transition. I'll color that momentarily so you can see it better. So just to remember, with the directional blend, because we also have a set called oriented, this is always just using the standard UVs of the model. It isn't doing anything special in terms of projection. It is just using a directional vector to control the blending between material 1 and material 2. Wonderful. So next up, let's play with the glass shader. One of my favorites. I wish I could use it even more than I already do. Let's create a new sphere. And let's create a new material. Glass test. Alloy, glass. And you'll notice there are high quality and low quality. I'll explain the difference of these after I explain how the glass shader actually works. And so the way glass functions is this is a multi-pass shader. It's forward only, like anything that's transparent, and it behaves a little bit differently than, say, just an alloy core shader set to transparent. The first thing you'll notice is that basically whatever your tint color is going to be multiplied over whatever the background is. So this is really useful if you want, say, a transparent material that has a lot of solidity to it. Think of it more like dyed glass, where there's actually suspended colored particulate inside the material. You'll also notice, as I come up here, that this distorts what is behind it. And that's because the glass shader is using grab pass distortion. And that's what the high and low quality difference is. Basically, the high quality glass shader is using a unique grab pass per object, which, as you might imagine, can get expensive very fast. I would never use more than, say, 3 to 4 objects at once, at most, with the high quality glass shader, because you're incurring that grab pass cost. The low quality glass shader, which in this case looks no different because we just have a single object, is using a shared grab pass for every single object that has the low quality glass shader on it. And you can see the difference in that if I, say, duplicate this object and then pop this one behind here, as we look through these, because these are using the same grab pass, this glass object is not visible through this one. Basically, their refractive grab is unified. Whereas if I set this to alloy, glass, high quality, we not only see it twice, but we actually get the doubled distortion, which can become a little more obvious if I actually just throw a bark normal on there. It might be a little too strong to really see through well. Let's knock the spec down a bit. And we can see that we get much more sort of wibbly distortion there. And so when using glass, this is always going to be something that you really have to tune by hand with the profiler and make a case-by-case decision on whether that distortive effect is aesthetically impactful enough to be worth the incurred performance cost, and whether when using the low-quality glass shader, if you run into any sort of draw order issues related to the fact that they're all sharing that pass. You'll also notice there's a property group for this, which is just the distortion properties. We can bring the distortion in and out there. we can change its intensity. And so this is the overall intensity, but we don't necessarily need a normal map for this distortion. You'll notice that it was distorting slightly just being a sphere. That's what this slider is for. This is called geometry influence, which is just how much the actual normal direction of the underlying geometry, independent of the normal map, affects the distortion. So really fun for lens effects. And as you can see, just by scaling this sphere, it alters the way that distortion functions. Beautiful. So that's the glass shader. If you want to look at it in context, in Alloy 3 samples, in the loot scene, there I'm using it on the potion bottles. Right there. Wonderful. So next up is a shader type that is similar to the directional blend, but has some important differences to it. So let's go ahead and create another new material for ourselves. Pop that on there. And these are the oriented shaders. So this is oriented blend is another type of material 1, material 2 kind of blending. The difference is that the second material that's being blended over does not use the UVs of the mesh, but is projected downward in world space. And so let's go ahead, let's build ourselves a sand material that's being blended over. So let's give it some normals as well. Let's set it to not be metallic, fairly rough, etc. And then let's give ourselves some sort of base material. So I believe I have some rusted plating here. Yes, that's the correct one. Rusted bolted plating. Beautiful. Let's repeat this. Maybe that's too many times. Cool. So we have this here. Note what happens as I move this sphere around. Basically, that material 2, that sand, is being blended over both of these objects in a consistent, on essentially down Y on XZ, in a consistent way, which means that when you end up having objects that say are partially embedded in that material that's being blended over, the texture lines up perfectly. And so I use this extensively in the Remnants demo. If you haven't checked that out, please do. It's basically an entire there's an entire scene in there that pretty much all has oriented blend on it, because I'm consistently blending sand onto the top surface of the entire environment. And I find that especially in sort of ruined or weathered contexts, this really helps knit props together with ground surface. And we have the same sort of settings that we did with the directional blend, in that we've got a weight we can bring in and out, we have a cutoff, and we have a blending range. This is noisy in this case because just the underlying normal of this second material is noisy. If you're using something cleaner, it would be obviously cleaner. So we can totally set this. Let's set this actually to be our sandstone. Sandstone. Bonk. Beautiful. So you can see as I rotate that around, our sand is always blending onto the top surface, and it's always consistent in world space. Wonderful. I hope you environment artists have fun with this. Oh, and very importantly, you'll also notice that there's a shader in that directory called Oriented Core. Basically, what Oriented Core should actually be the material that is on this ground plane, in that if you have a piece of geometry that you just want to be the world projected sort of ground material that things are being blended into, I can do this here. oriented core. Nothing's being blended together. It's literally just our world space. There we go. Our world space sand. As you can see, as I rotate this, it's just being projected downward, and I can move this around, and the texture stays in the same spot. Note that you can still change the repeats on this. You're just changing them relative to world space. And if you want things to still match up, you're going to have to make sure that the tiling is the same between any objects that you are blending together. Note, because scroll is on here, you can also do some really neat things if you wanted, say, sand moving very slowly across a surface. You could totally use this for, say, especially with some like particle effects and some wind going, this could be a really effective technique for having a sort of material blowing across another, especially if you, say, didn't even have the weight all the way up at 1.4. Tons of fun stuff to play with. Awesome. So that's the oriented shaders. So next up, let's create ourselves a cube here. I'm going to cover another section of alloy shaders here, which is the transmission shaders. Basically, it's a, let's call it a subsurface scattering approximation. They're under here, this transmission single-sided and double-sided. This is double-sided is useful in contexts where you just are, say, using sheets and you want a transmittive material. Which one of these you use can also be something that's worth experimenting with in terms of shadowing behavior. Obviously, transmittive materials don't receive shadows, but they can still cast them in certain contexts. So I'm going to turn this to transmittive. Note that you can have a transmittive material that is still opaque. So I'm going to pull this here. I'm going to knock the metallic down. Say, set this to dark gray. And this would be easier without any ambient, actually. So let's turn the ambient intensity and the reflection intensity to 0 so that we can, there we go. So we can just see the effect of this. On the front of the object, obviously it just looks like it's a normal, fairly diffusely lit object. We can make it a little shinier with our area light. But the cool thing about transmission materials is that we can rotate around and we actually can see the light coming through it. And this is controlled via the Transmission Properties group here. I have bump distortion defaults to 1 here, so if we actually turn this to 0, we can actually just see the light on the other side coming through the object. Even if we, say, set it to, let's see, set it to shadowed. So that is going to, I always forget with these, whether we want it to be single or double-sided. There we go. With single-sided, the object is not going to cast a shadow on itself. So with it being opaque, we can actually see the light coming through the object. This is even more obvious if we grab a spotlight to play with. Turn the intensity up on that. Boom. Beautiful. We can see it casting through. Now this doesn't have to be a constant effect either. Basically the alpha channel, even when you're using an opaque object here, you can, actually no, it's not there, it's the color effect here. We can control basically how intense this transmission effect is. And to see a better example of this actually in context with a real asset, if you open up the loot demo that's in the alloy samples, I've used the transmission shader in 2 places here. I've used it on the candle, which we can see here. We can see the light coming through. And I've used it on the paper as well, which is more obvious when we hit play. You can see the light that's flickering is actually showing through the paper. And for the candle, to get this looking as solid as I have, if we look at our maps here in color, I've used what's called a thickness map. And now, I believe these can now be baked in Substance Designer. I think you can also bake them in Nulled. In general, you don't necessarily always have to use what bakers call a thickness map to get a good result. Sometimes you can take an ambient occlusion map and invert it and play it with it based on what sort of object you're trying to make transmissive. It may be that recessed areas are quote-unquote the thinnest parts of them, so you want the light to show through more there. Basically, just play around with different kinds of bake data for getting various sorts of effects. Transmission is useful for everything from wax to thin cloth to marble, even in certain cases, if you want some light energy to be showing through it. In the case of this candle material, let's play with some of its settings. We can actually see that you can use the sort of facing direction of the mesh and its normal map to distort the way that this transmission occurs. So if I turn bump distortion up, in some ways it almost turns the transmittive effect into being almost rim-like, in that we're going to see it on sort of fringes and areas where the angle is more perpendicular to the view vector, whereas without bump distortion, it's far more direct and powerful. And we also have some fall-off parameters here we can play with. So yeah, just remember, this is a forward-only shader, which means that if you have a lot of transmittive objects and you have a lot of real-time lights and you want things to look correct, you are going to have to turn up your pixel light count in your quality settings, and that is going to incur performance penalties. And so any sort of specialist forward-only shader in Alloy simply needs to be used with care, and you need to understand what the performance implications are going to be based on what your scene configuration is. Awesome. So that's the transmission shader. So I actually led off with showing you, in many ways, some of the more exotic blending shaders. So this one might not be as impressive to you, but if you just need a straight Material 1, Material 2 blend, just using a mask or Vertex Alpha tint, there's the weighted blend shader. And this is, I'm just going to create very simple Material 1, Material 2. If we this just takes in a straight sort of black and white map for its blend properties. I can just say grab a caustic here, let's just say. And you can either use this absolutely straight as a mask, in which case you basically want, what is it? Yes. I always get this messed up. Yes. Blend at 1, cut off at 0 is going to give you a pretty much straight Material 1 to Material 2 blend, if you just wanted to use the raw mask data. But you also, if you ever want to animate that blend, we've left exposed sort of weight, cutoff, and blending ranges. There we go. For if you want to use your mask in a slightly more exotic manner. As I mentioned before, this doesn't necessarily need a mask as well. I know with a lot of people who do, say, large environment art, you don't want to have all of these really high-res blending textures, and you may want to actually encode that Material 1 to Material 2 blending right in the vertex color. And so I'm going to do this the derpy way, because I don't have a vertex painting module installed for Unity at the moment. I'm just going to do this in Maya. I'm going to just create a very, very simple cube and do some vertex color transitions on it. So super simply, I'm just going to select the top surface here. What is the terrible way that this is done in Maya? So let's just use apply color. So I'm just going to apply red with an alpha of 0 to the top, which will look like that, and then blue with an alpha of 1 to the bottom. And let's just go ahead and export this mesh. Excellent. We have our box. Let's go ahead and bring it in. So just to show a couple things quickly, I know we were talking about weighted blend, but now that I have a mesh in here with vertex color data, in its main textures, I can drag up this slider and bring that just the RGB component of that vertex color in for blending purposes. Or you could do both of these. I can set this to be a weighted blend shader. Use no mask input whatsoever, and just use, let's create 2 tints. Let's pick something, say, like green and orange. I can bring in the Vertex Alpha tint here to blend between those materials. And so I can still use the cutoff and blend parameters here to control the way that functions. And so cutoff of 0 and a blend of 1 will basically just use the raw Vertex Alpha tint. I can still bring that in and out independently if I want to. And if I wanted to truly make colors clash, I could use the RGB component of it as well, being blended together. Obviously, I don't suggest you use Maya for inputting vertex colors like this, especially if using the alpha, because just making the object go completely transparent like this is not a useful authoring strategy. But I'm sure there are some good vertex color painting assets on the asset store for using this sort of functionality. In that same category, while we're on the topic, there is also a brand new shader here called Vertex Blend 4 Splat. This is in some ways a sort of terrain replacement shader for people using vertex colors, in that we have 4 inputs which use what are called this is our sort of terrain packed map style, in that these don't use a full alloy packed map. You aren't defining metallic and occlusion per pixel. You're defining them sort of per material, so we don't run out of texture samplers. But in this case, this is actually just using RGBA vertex colors to blend in 4 different materials, which doesn't look that good on our sort of sample cube here, but if you were to bring in a properly configured mesh, this would work fine for. I don't have an example for this yet because we just added this shader, but there'll be a follow-up video sometime soon, especially once I find a vertex painting asset to officially endorse, where I'll cover a little bit more in terms of this sort of side of the alloy authoring pipeline. So on to the character shaders. This section's going to be pretty abbreviated, as I will be the first to admit I'm not a character guy. I'm not a character artist. I don't have personal experience with all of the nuances for, say, achieving really realistic skin. We've designed this part of the alloy set along with folks who do, however. So I'm going to go over very briefly our example and what I know to be the sort of things that you can modify with the skin. But if you need a more in-depth overview of that, we have one of our buddies, KC, who's a great character artist, has been working on 2 absolutely gorgeous characters using alloy, and he'll have some videos out of his workflow for those soon. But until then, I'm just going to go over a couple things in regards to the skin and the eye shader that you should be aware of. There we go. The alloy eye shader has a whole bunch of eye-specific properties in it that you might want to play with. The first of which is that there are a couple deviations from what maps are being used relative to a standard core shader. In the alpha of the base color, we are defining in that channel the depth of the eye for the iris, which is actually sort of poking back into the eye. In the packed map, instead of putting a metallic channel in the red part of the material map packer, we're putting an iris mask, as we have sort of separate properties for the sclera, cornea, and iris. In regards to the normals, you're probably going to want to exaggerate them a little bit so that you get a little bit more of dynamic shading on the front. But once again, Casey will cover the reasoning for that in a later video. But for the iris itself, the reason we have that mask is that we can tint out, we sort of have a tint mask for the iris itself. We have scattering properties for it. I'm not quite sure how those will affect things. I always feel like such a nubbin using character shaders. It's totally out of my element. Specular tint for the iris. We have POM'd depth for the iris. And we have a pupil dilation parameter, which is once again sort of using the POM effect. Super fun. And then for the skin shader, the things that you should be aware of to start playing around with the skin shader is that it takes in a couple special maps. The first is that we have a transmission map for the skin, and that should go in the alpha channel of your base color map. And so this is similar with the transmission shader in that we have basically a thickness map. You can see on this character, I'm not going all the way to black and white. You're going to probably just need to tweak that based on whatever your mesh is and whatever look you're trying to achieve. Obviously, thinner parts of the face, the ears, the nose, fringes of the lips, etc., are going to be brighter on this map. And then in the packed map, in case you have a texture canvas where you both need skin and not skin regions, the red channel is a skin mask, which in the case of this is just pure white. But might be different based on how you have your model set up. If we look at the skin-specific property groups, we have scattering and transmission properties. The transmission properties are the exact same as they are on the transmission shader. And then the scattering properties are skin-specific. It has a lookup texture, which 99% of the time you are not going to want to change this. This is basically a lookup for human skin-specific light scattering, intensity, and hue. If you are, however, using the skin shader on something that isn't human skin, like say you have an orc character that's green, or you're doing what I'm doing here, which is using the skin shader on sort of more poly-oriented hair, you might want to change this. I would suggest, if you are modifying this map, that you duplicate it here and only change its hue. So if you've got like a blue alien, shift this reddish hue to blue. If you have an orc, shift it to green. Don't mess with the luminance of this map if you possibly can, because it's just, you can't really predict how that's going to change things for the worse. So two other things I want to mention in the skin-specific settings is one of them is called AO saturation. This basically changes the way the ambient occlusion map is interpreted for the skin. My goodness, the shader previews for skin always look so creepy. And basically what this does is it just brings a little more color into the areas that are being occluded. So I wouldn't necessarily have it up at 1, but this can definitely bring a good deal more warmth into a model. And then the second one is called bump blur. What this is doing is it's just blurring the normal map for the diffuse pass of the model. It's not doing it for the specular pass. So let's see, we can really see this in, say, the crinkles around the nose, that with no bump blur, this ends up looking way sharper than it should be, which means that it ends up sort of making, the sharp normal map ends up giving the face slightly a sort of waxy or cast look, whereas the bump blur sort of smooths out the diffuse lighting. So we've, from testing and from working with other artists, we found a default value of something around 0.7 tends to give you the best result for that. So yeah, so hopefully that'll get you started on playing with the character shaders. I would like to be able to have sort of more robust tutorial information for those, but as I said, it's out of my element, but it's something we're working on. And then last but not least in the shader list is a couple things we have in here, once again, mainly for VFX purposes. There is an Unlit shader that still has all of your standard property groups but doesn't receive standard lighting in case you just want to use things like emission and rim but still have a solid object that is just an unlit flat color behind it. And also, I heartily encourage you to check out the particle shaders that are included with Alloy. They're very much the sort of Unity stock implementations of things like additive, alpha blended, multiply, etc. But we've added a couple of extra features that you might find useful. They have our standard Alloy texture properties, so you can say set up scrolling on X and Y. They use our intensity gains, so these are all inherently HDR in terms of how emissive they are. And in addition, there are a couple property groups that you can add into them that you can see in use in the Remnants demo that I mentioned before. There are particle effects properties, so if you want to set up sort of masking, either a single or dual mask, let's actually go ahead and pop this. Let's actually just pop this onto this quad to show you what I'm talking about. So we're using just particles additive here. I can throw on some caustics and set up some scrolling effects on those. -0.2, -0.2. Beautiful. Throw up the intensity gain there. And so if you're looking for interesting ways to make your particles look that aren't just, say, using static sprites or sprite sheets, you can use some of these features. And these are available on all the different Alloy particle shaders. In addition, there's something called rim fade, which I've found really useful when using particle shaders on something like light shafts, where you want it to basically fade away when we sort of come really perpendicular to the surface, i.e. in a situation that would break the illusion that you are looking at something flat. You can add the rim fade property group to it. Just for comparison, weight 0, we can still see it when we're super off axis. Weight 1, it completely fades out. And we have a similar sort of fall off variable to rim lighting for achieving this. This works really well on cylinders. This works really well on sort of stacks of light shafts coming down from a ceiling. And then lastly, we have distance fade properties, which this can be a little bit hard to control, but is similarly useful for controlling the problem of if I have very large particles and my camera is coming super close to them and might be going through it. This will allow you to, and you have to play around. This is in like depth buffer space, so it can be a little difficult to control, but this allows you to have the particle start fading out as it approaches the near frustum of the camera. Once again, it's something I used in Remnants. I don't know good values off the top of my head. You'll have to play with it. Wonderful. So that's the particle set. So to wrap things up, as I promised at the beginning, I'm going to go through the process of setting up some image effects to use with Alloy. And I'm going to do that using the loot demo, which once you sort of load it up out of the samples, you can see this doesn't quite look the way that it did in the screenshots. And part of that has to do with the fact that when sort of distributing a package, the project settings don't come with it, and part of it is because we don't have our post, and you always need your post. So the first thing I'm going to do is I'm going to calm down the exposure on this back to 1, which is what it should have been. Beautiful. I'm going to grab my main camera, make sure that HDR is set, and I'm going to put an image effects stack on this. So I'm going to put, remember, when you're putting image effects on a camera, the ordering is very important, and you always want the image effects that need to occur in HDR to go on first. And so that's going to be things like bloom, that's going to be things such as certain types of SSAO. I've got an early release copy of Sonic Ether's SSAO here, which I'm going to pop on because I totes love it, especially because it adds some wonderful color bleeding in here. So I'm going to turn it down a little bit. Let's see, turn off reduce self-bleeding, color bleed amount, not quite as intense. Beautiful. And then I'm going to throw on Sonic Ether's Bloom. As I said before, just absolutely critical. Turn up the bloom intensity a bunch, because why not? And then most importantly, if you're in HDR, you must have an image effect on your camera to remap down to LDR. And so this is going to be image effects, color adjustments, tone mapping. Now, which settings are best for tone mapping is oftentimes contentious. There is not one answer for this. Some people like to tone map in a way that actually gives you a fairly washed out, not very contrasty image, because they're going to color correct further, and when you're color correcting in LDR, you tend to want the widest range possible, so you don't have a super over-ramped tone mapping result. So to do that, oftentimes, optimized Haji Dawson or Hable tends to give you a slightly more washed out look. I tend to just use photographic and use an exposure somewhere in between 1.2 and 1.8 based upon the result that I'm looking for. And then, of course, why not? We're in Unity, so let's throw on just a touch of vignetting. No chromatic aberration. Bad. Overused effect. Turn that off. Awesome. And just very subtle vignetting and very subtle blurred corners. Beautiful. We're all set up. Well, thanks for watching this alloy crash course. I hope I haven't talked your ear off too much, and I hope that this helps you get set up and going. Based upon people's needs, I'm going to do more specialized tutorials in the future. If you're looking for specific help in how to use anything in the set, I heartily encourage you to jump on our forum thread and ask. It's oftentimes very difficult with a set this big for me to know exactly what people's priorities are and what hasn't been communicated clearly enough. So please don't feel free to hit me up on the forum thread, hit me up on Twitter, wherever. Have a wonderful week. Take care.